We now begin our discussion of the Doodles activity subclass. Now, we start here with the import declarations for the Doodles activity, and there are a couple of new imports in particular that I want to focus on. You'll notice here at line 5 that we're working with class atomic boolean from the java.util.concurrent.atomic package. An atomic boolean is a boolean value that is thread safe. And the reason we're using this Boolean value in the example is to determine when there is a dialog displayed on the screen. And the reason we need to do that is because of the fact that this app uses sensor events. Sensor events are handled in a separate thread of execution from the regular GUI events. If the user, for example, has a color dialog on the screen at the moment and accidentally shakes the device too hard, it's possible that the sensor event could occur that we use to determine whether the user wants to erase the current drawing on the screen. And we don't want the confirmation dialog for erasing the image to appear on the screen when there's already another dialog on the screen. So because we need this Boolean variable from separate threads of execution, the GUI thread and the sensor event handling thread, we had to make it an atomic Boolean so that we can make sure that when it's set by the different threads of execution, that in fact it's done in a thread safe manner. So we'll see how we use that atomic Boolean object as we work our way through this class. Now, another new feature that we're using is the dialog class because we're creating some custom dialogues. So we'll take a look at that class in this example. And the other key new features are from the Android.hardware package, where we're using sensor, sensor event listener, and sensor manager. Now, the sensor class has constants that represent the various types of sensors that are available on the device, such as the accelerometer, which is what we use to test for shaking in this example. But they also, depending on the device, you may have lots of other sensors built into the device, like gyroscopes and sensors that like barometers and altimeters, etc. So the sensor class provides constants that allow you to identify the different sensors you wish to listen to in a given app. Sensor events are what are passed to the listener methods for processing the different types of events. When you want to listen for sensor events, you implement the sensor event listener interface. And to set up an app so that it can listen for sensor events, you take advantage of the sensor manager service that is provided by Android. Now, as you can see here, our Doodles class extends activity. So this is the activity for this particular app. We have only one activity. And then we have a number of instance variables and fields that we've declared in this app. We have one to refer to the Doodle view so that the activity can talk to the Doodle view as we run the app. The sensor manager variable is going to be used to store a reference to the sensor manager service so that we can interact with it and register for accelerometer events. The three floating point values for acceleration, current acceleration, and last acceleration will be used to help us determine if the user shook the device hard enough to initiate the erasing of what's on the screen. As we mentioned, the atomic Boolean variable is going to be used to determine if a dialog is on the screen at a given time from multiple different threads of execution, and we've gone ahead here and directly initialized that variable with a new atomic Boolean object. By default, the value inside of that object is false. Next, we have our menu IDs, which we've learned about previously in earlier apps. These will be used to uniquely identify the 5 different menu items that you saw displayed that allow us to allow the user to set the color, the line width, turn the fingers into erasers, clear the screen, and save the image. At line 47, we have a constant called acceleration threshold, which we've set to 15,000. And basically, the way we came up with that number is by trial and error as we tested this app on a variety of different phones and tablet devices. And then finally, we have an instance variable called current dialog, to which we will assign whatever dialog is currently displayed on the screen.